Look at the board, please. All right, introduction to sequences. Please take a look at your vocabulary words. A sequence is an ordered set of numbers. Each number is called a term. A recursive formula, which is actually what you guys were using when you were determining how many sides the snowflake had, is a rule that tells you how to write the terms of a sequence using the preceding term. So what you did to find how many sides there were in the snowflake, you multiplied 4 by the previous number each time. And that's how you got the next one. So for example, if I'm taking a look at a sequence with the first term, a sub 1 equals 4, and my recursive formula, a sub n is equal to 3 times a sub n minus 1 minus 2, do you see the a sub n minus 1? That means the previous term. So all you would do, the first term is given to me, that's 4. The second term, what I do is I type in 3 times the previous term minus 2. So the previous term is 4. That is 3 times 4 minus 2. 12 minus 2 is 10, so that's how we get our next term. Okay? To find the third term, 3 times the previous term, which is 10, minus 2, which is 28. The fourth term, 3 times 28 minus 2, which is 82. So on and so forth. You can find as many terms as you need. Okay, so let's give it a shot. Our first term is negative 8. And our recursive formula is the previous term plus 3. Okay? Well, what is negative 8 plus 3?
Negative 5.
Negative 5. So that is the second term. That's what a sub 2 means. All right, to find the third term, it's the previous term plus 3. So what is negative 5 plus 3?
Negative 2.
Negative 2. The fourth term, the previous term plus 3. So that's negative 2 plus 3 is?
1.
Positive 1. The fifth term, the previous term plus 3. So that's 1 plus 3 equals 4.
This is easy.
Okay?
Pretty basic arithmetic.
Yeah, you're right. Okay? Let's take a look at number 2. Here, our first term is 2, and our recursive formula is negative 5 times the previous term. Okay? So, to find the second term, it's negative 5 times 2, which is negative 10. Our third term, negative 5 times what number? Negative 10. So, negative 5 times negative 10 is 50. Our fourth term, what do I do? Negative 5 times 50, which is negative 250. Okay? And what do I do with the fifth term? Negative 5 times negative 250, which is how much? 1250? Okay. All right, I'd like to see you do the next two on your own, please. Do on your own. Oh, done?
Yeah.
Oh,
A sub 5.
I got you.
So it's
You're right here. This is negative 250. All right, so let me see everybody doing this too.
How do you get
The first term is 6. The first term is 6, so now you go to the second term.
So it'd be 6 times
2, 6. 2 times 6 minus 1. Right, that's it. The original formula is 2 times 3 whatever you call it, 4.
I know that.
Right. That means the previous.
Easy.
So 4 times negative 1 is negative 4. Negative 4
Yo, Billy, come over here.
No, this is Billy.
Oh, so here.
That's mine.
Negative.
Yep, that's what I got too.
So the second term is
That's just what it hurts.
Why are you looking at the camera?
The other way we were doing that.
This means 2 times the previous one. So to find your second term, it is 2 times 6 minus 1. Okay, I need it.
Hey,
Wait.
for what?
All right, can I get a volunteer, please?
Go.
Just put the answers up on the board.
I'll do it now.
Macy,
Can I do the
how
other
about
one?
3 and Will 4?
I'm running big.
Wait, we actually have to all do it.
Yes. And both of you can write on there at the same time.
It's just one of these, okay?
You do yours.
R-E-I. You can do it at the same time.
But I want blue. Green is lame. Just do it.
Okay.
Oh my god.
Yes, it is.
Macy, don't you have a sock in here?
Dang it, I need to use
Why is it like a small one? You put a sock in your hair. Oh, never tried it? Yeah. Put a what in your hair? Sock. Oh, sock.
Yeah. She's like,
You literally. No, I mean I've seen the ones that are like the ballerina one or whatever. The ones that there's like the ballerina shirt, whatever. Okay. No, the ones that it just looks like a scrunchie.
Oh no, I have one for ballet. You put your braces in like
Math.
Okay.
No, that one.
Does it say one?
Same one.
Like in the commercials, one that like you like hold it and you like curl your
I
hair.
don't know what it is about smart boards, but they always hate me.
A sock.
takes a little bit to
I
get
didn't know a
used to.
sock.
That was a wonderful thing to put on the table like this. Smart boards hate them. Perfect thing to put on those.
Just like, what do you mean? What do you mean? Yeah, what do you mean? Well, you like cut it, like you get like a long sock, and you cut the toe off, and then you like roll it, so it looks like a donut. And you put your hair on, put your hair
What I do every day.
Wait.
It's my sock.
If I ever do it, all I do is I'll just take my hair and I'll twist it, and then I just snap it down. I mean, most of the time it'll like, it's like that perfect, but it's pretty dazzling good looking.
Your second one is negative. 16 should be negative. Yes.
Oh, your fingers
Because 4 times negative 4 is negative 16. And then that means you'll plug in that negative 6. There you go.
Wait, so 16 supposed to be negative?
Yeah.
I didn't
Yeah.
mean to.
It's
fine.
I want to play to negatives. Never mind, it's not to negatives, right?
Your mother kind of bratty.
Yeah, it's 64. I could have done that, but I didn't.
Still, I'm not going to do it today.
Okay.
All right, excellent job. Both of those students did a good job and got all 100% correct. Please check your work. How many people got those answers? Good. Very good. All right. So, Sierra, you ready? Here we go. Moving on. All right, now. I need everybody looking at the board, looking at the next page of notes. You can use difference patterns to write possible rules for your sequences. So remember, we've already talked about differences. If the first differences are constant, it's linear. If the second differences are constant, it's quadratic. And if the ratios are constant, it's exponential. Okay, so take a look here. It says write a possible rule for the nth term of the sequence. We have 8, 14, 20, 26, and 32. What do you notice here? These numbers are increasing by 6 each time. That means the first differences are constant. So that means we're talking about a linear relationship. Okay? Now, let's take a look here and see if we can write these rules. The first,
I got this.
Okay, thank you.
Just draw a big circle around it.
Just put that anywhere.
Touch the middle.
That's what I get for mixing the software.
I go solo. Okay.
All right, so our first differences are -2. Quiet now. Will. What's the first term? 3 is the first term. Good. Okay, it says each term is 2 less than the previous term. To demonstrate the previous term, we use n-1. Okay? So, here we go. Here's our rule. You write down the first term. Now, each term is 2 less than the previous term, so we say -2 times each previous term. And now what we're going to do is simplify. So I can distribute the -2. This is 3 minus 2n plus 2. So my final answer would be 5 minus 2n. Okay? Because I distributed the -2 times the -1. That's how I got plus 2. And then I said 3 plus 2 is 5. Okay? All right, yes, question. Yes, the previous term. All right, let's take a look here. I need people to stop talking. Look at the board. What's the differences here? I'm going -2 to 0 to 2 to 4 to 6. What's happening each time? We're adding 2 each time. Now, what's the first term? -2. Now, each term is, okay, 2 more than,
and then right after